In this section, we're going to return to one of the first Swift types we used, string. As we have hinted at many times so far, there's a lot of complexity to this type which we didn't want to explore too earlier on. In this section, we'll introduce the background for this complexity and a few approaches you can use to master this type without getting lost in its details. Then we'll explore using functional transforms on collections. You may have noticed that up to this point we've tried to keep our usage of string quite simple. We've covered creating strings, interpolating strings, splitting strings, and concatenating strings. This is because Swift's string type is actually very complex and can be hard to work with at times. In this section we're going to cover a deeper level of this complexity, but still focused on the most common operations. String is a type that received a lot of attention in Swift 4 in order to address criticisms aimed at its complex API. Therefore, we will be using Swift 4 for our examples here, since there are some significant changes. First off, let's consider why string is such a surprisingly complex type, if compared to strings in other languages. Swift's string type has a very strict approach to implementing the Unicode standard, and much more than many other older languages, although often for historical reasons. Since Swift is a very new language, the development team have tried to create a very correct implementation. Unicode is a very large topic and we won't cover it in detail here. However, the main point for understanding strings complexity is this. Most languages represent strings as an array of characters. A strict implementation of Unicode makes this impossible. Therefore, you should generally not think of a Swift string as an array of characters. So does this mean we can subscript a Swift string? Indeed, we cannot subscript a Swift string with an integer index, as you may be used to doing in many other languages. This begins to introduce the unfamiliar complexity of working with Swift strings. In fact, it is possible to subscript a string with an integer index, but first we have to introduce the concept of string views. To handle the complexity of Unicode, Swift's string type provides 4 different views of the string. We have characters, UTF-8, UTF-16, and Unicode scalars. But why? To illustrate, let's try changing the string to a non-ASCII, non-English string. I've changed the string to some simple French. Look what happens when we try to take the count value of each view. Each view has a different value as a result of the different way the encoding represents a string, and this will often be true for non-ASCII, especially non-English text. Notice that the first view, characters, has the value that you probably expected. The character view closest resembles what a reader of the string would consider as the length of the string. So, how should you take the length of a Swift string? This is one important point that has changed in Swift 4. Previously, it was always necessary to explicitly access a view in order to take count of the string. In Swift 4, however, this has been changed and string has a count method that returns the character view count. This reflects what most people would expect the value to be and is an attempt to make strings easier to work with. However, this brings us to an important tip. String has no simple length method as with other languages, since taking the length of a non-ASCII string is not a simple operation. This is by design. Instead, we suggest the following tips. Avoid using the equality operator with count on Swift strings, and instead compare the length to minimums and maximums. Consider being explicit about the view you are working with. A common example would be checking for a minimum password length in some kind of application form. In this case, you might consider using the character view, and you might consider doing this explicitly, since it's the most user-appropriate representation. Another example would be limiting a string based on storage space. If you're going to encode your string as UTF-8 for storage, you might take this into account when checking the string size and using the count of the UTF-8 view. So, you might consider your storage encoding. Finally, a simple tip, but a great habit to get into. Prefer using the isEmptyString method over comparing the string length to 0. The next important topic to cover is searching strings and substrings. String has a large number of searching methods. We would just like to cover the most general case here, which is searching for substrings. This is a good point to begin your journey in the string searching and mutating APIs. We'll take a simple string variable and search for a substring. The searching method is quite simple, range of string. Since the string might not be found, this method returns an optional. So first we need to unwrap it. Running this code has a quite complex result. The important thing to know is that we're working with a range type. We've used this basic type before, so we know that its most important properties are the lower bound and the upper bound. Don't worry about the complexity of the return generic type. Instead, concentrate on using the lower and upper bound properties. So let's modify the string using the search range. We now have a working range, so let's insert into the string variable using the search range. Here we're going to mutate the string's value for simplicity. The insert method takes another string and a range index. We now have a working range, so let's insert into the string variable using the search range we received. Here we're going to mutate the string's value itself for simplicity. The insert method takes another string and a range index. We can't easily generate a range index ourselves, but instead we can use the range we generated from the search method. As you can see, this becomes a clear and readable method call. Insert contents of string at range. Since we're using the upper bound, we will insert after the substring, creating the result, a needle in a very big haystack. Now let's do an insert using the lower bound, and the call is very similar. Insert contents of string at range.lowerBound. Note that I modified using the upper bound first so that the range would still be valid when I inserted at the lower bound. The range will of course not update itself automatically when we modify the string. Finally, let's add another example working directly on the original string. String provides start index and end index properties that allow us to insert using the same method at the beginning and the end of the string. We've barely scratched the surface of the string API here. It's truly a surprisingly complex type and can be very unwelcoming to new users. Instead, we would like to arm you with the broad knowledge you need to master string. So, here are a few tips to sum up. First of all, you may be experienced using strings in another programming language that allow you subscript indexing. Try to get away from this thinking. Don't think about Swift's string as an array of characters. Think about string as an opaque type. Use searching methods to generate ranges, and then use those ranges to modify a string. Then the API becomes easy to work with for most of your common needs. You also have the start index and end index properties to use the same methods we looked at. Finally, bear in mind the concept of string views. They could become important to you when storing or transmitting text, especially large amounts of text. We also recommend reading an introduction to Unicode to help understand why string was implemented in this way, if you haven't done so before. We have of course only scratched the surface of the string API. To learn more, please visit the developer documentation.